Some games, like the old school Asteroids, dealt with the screen bounce by wrapping the player around the map. It helped the player to avoid being hit, but more importantly made the game more difficult since small rocks could unexpectedly hit the ship, and arcades made money by making you keep putting in the coins because you have died. In this video, we are going to recreate this game mechanic in Unity. Hi, I'm Peter, and welcome to Sunny Valley Studio Tutorials. Before we start, if you want to learn how to improve the look of your games by creating custom Unity shaders, check out JetEli channel, the link will be in the description of this video. Here is our game prototype. Now we can move our ship, but it flies away from the gameplay view. We can also shoot bullets, but they also fly away, but they luckily get destroyed after some delay. Now, another important fact is that we have a main camera that is orthographic, and I will assume that we are moving the background, not the ship, so we are going to create bounding box around the camera view, and this will be the base for our bounce logic for our game. Now what we can do is either collide with the bounce, so not allow the player to move away from the screen, or we can try to wrap the player around, and we are going to explore how to achieve both of those results. Now, to get any kind of logic working that allows us to detect collision with the bounce of our level, we first need to calculate them. So we are going to create in the hierarchy new game object. Let's call it screen bounce. And again, basically this is what it will be. Those will be screen bounce that are based on the camera and what the camera sees. Now we will need to have a script that will calculate those bounce. I will create a new C# script called the same space screen bounce, and I will open it up in Visual Studio. Okay, so this will be a new script. We can delete the start and update, and first thing that I will need to have is a box collider. So I will add an attribute to the screen bounce class, require component type of box collider 2D. Now this will add automatically the box collider 2D to the objects to which you add the screen bounce script, but only to the new object. So if any object in your game has already the screen bounce script, the box collider 2D will not be automatically added. Next, we are going to have a couple of fields. First, we are going to have a public camera, main camera reference. This will be the reference to the main camera, so we are sure that we have this, because based on the camera parameters, we are going to calculate our screen bounce. And we are going to have this box collider 2D box collider that we are going to change or modify its size based on our calculations, so that we can detect on trigger exit where an object exits our box collider. Now we are going to also need a public Unity event that passes collider 2D to a listener that will act based on the message from our box collider. So to have the Unity events class, we need to right click on it, quick actions, and say using Unity engine.events. This library will be imported at the top, and at the end we are going to have a serialized field private float teleport offset, since this will allow us to wrap our player and teleport it basically to the other side of the screen with some small offsets, so we are not constantly teleporting it from one side to the other, because it is constantly outside of the bounce. First of all, we are going to need an awake method. So the private void awake will contain this main camera transform.local scale. We are going to set the local scale of the camera to be vector 3.1, just in case someone has changed the scale of our main camera. And we will need to grab the box collider reference equals get component box collider 2D, and we need to ensure that the box collider is a trigger, so that our objects on the screen will not collide with it. Now, next we are going to have a start method, and our private void start method will contain transform.position equals vector 3.0. This is essential for our system of camera bounce or screen bounce to work. We need to put it in the center of the screen. And we are going to have an update bounce size method. So right click, quick actions, and generate this method. And this will be a public method, because in case we want to move camera or zoom out or into our game, we may want to update our camera bounce or the screen space bounce that will affect our objects. Now inside this update bounce size, we are going to create a float y. This is the y position or y size equals main camera.orthographic size times 2. If we take a look at the documentation for the camera orthographic size, we are going to read that the orthographic size is just half size when in orthographic mode, and this is the half size of the vertical viewing volume. So basically this is the height of our screen, and the horizontal size can be calculated by multiplying the orthographic size times 2 by the aspect ratio of our camera. So if we take a look at our code, the y, or actually this is y size, so the height of our bounds is main camera.orthographic size times 2. So now we have the height of the area of our level. To calculate the width, we need to calculate y size times main camera.aspect ratio, and to actually modify our box collider, we are going to calculate vector2 box collider's size equals a new vector2 y size times main camera.aspect ratio. This calculates as the width of our level area or level bounds, and y size will be the height of it. And all we need to do is set our box collider.size equals box collider size, and this should make our box collider of the size of our level, or what basically our camera sees. Okay, great. If we take a look at our screen bounds, if we add to it our screen bounds script, the box collider will appear here, and now we have no main camera reference, so let's drag our main camera, and if we press play, we should see now that our box collider is of the size of our what our camera sees basically. But now nothing really happens yet. That's why we need to add some more methods to our screen bounds script. So to handle first our rigid body, all we need to do is add on trigger exit 2D method, and it will take in collider to the collision. And in our code, all we need to do is call exit trigger fired ?.invoke with the collision. So we are going to invoke this Unity event to send the reference to this collider to the to any script that is listening to this event, and we are going to create the logic to handle it in a separate script. But for now, we are also going to create some logic to check if we are out of bounds. So we are going to create public bool mi out of bounds method that takes in vector3 world position. Basically, we want to return if mathf.abs, so we are going to calculate an absolute value of the world position.x. The idea is that we are in the 0.000 with our screen bounds, because that's what we set at the start of our game. So our ship can have negative values, both x and y, or positive. That's why we need to calculate the absolute value, because basically our box collider, we have the size of our screen. So if we take half of our box collider size in each direction, we can calculate if the x position of our ship is greater, so if it is here, on y-axis or on x-axis or on both axes, and that is when our ship is out of the bounds of our level. So that's what we want to calculate. So in the code, it will simply look like mathf.abs, so absolute value of world position x. If this is greater than mathf.abs box collider bounds mean x, so this is the mean x value, basically from 0 to minus 14 or 28, I think, for my screen. But basically, if we take an absolute value, we are going to get a positive result, and we can take box collider bounds mean or max. Basically, this will be the same value but with a different sign. And this is a vector 3, so this is x, y, and z of the bottom left corner of our box collider, and max will be the top right corner. Basically, if we calculate it for x, also we need to check or mathf.abs world position y. If this is greater than mathf.abs box collider bounds mean y, this will check on the y direction, in the y direction, if our world position is outside of the bounds. If any of those statements is true, we are going to return true, so we are going to return that we are indeed out of the bounds of the game level. And let's take a look at the last method that we will need to have. Let me put it all in one screen. So basically what we need to calculate is public vector2 calculate wrapped position. So based on the vector2 world position, we want to calculate the position to which we should teleport our player or an object if you want to wrap it around the screen. So if we check that we are out of the bounds, we can call this method, And here we need to calculate again bool x bounds results. So we have the same calculation as we had above, and for bool y bounds result we need to calculate it for y. And basically based on this we can decide in which direction we should teleport our player. And we are going to also calculate the sign, so vector2 sign of our vector of the world position equals new vector2 math.sign, and this returns basically -1 or 1 based on what is the sign of the x, y and z. For us it will be x position and the second will be y position, because this will be useful for us when calculating the new position. So based on the x bounds result and the y bounds result, we decide if we are in the corner, if we are outside of the x, in the x-axis, or outside of the y-axis, or if we want to simply return the world position. What we want to do is, if we are in the corner, that it means that both of those will be true. We are outside of the y and x bounds. In case of this, we want to return a vector2 scale, which is simply multiplication component-wise of the world position, so of our x and y position of our ship, times vector2.1 minus 1. So basically we want to calculate the opposite vector on the other side of the center of our coordinate system, and we want to add to it vector2.scale. We want to add some offset to it. That's why at the top here we had this serialized field private float teleport offset 0.2f, and basically this will ensure that we are not constantly teleporting from one side to the other side, because we are constantly outside of the bounds. So for our corner we need to add to the value of our new position vector2.scale a new vector2 teleport offset, and we need to multiply it by the sign of the vector. Now I know this seems like a lot of math, so let's analyze it. We have our ship and it flies in this direction. First, our calculation will reverse this by multiplying our value of the world position vector2.scale world position times vector2.1 times -1. So basically we swap the sign if we were moving here, so x and y was the positive values, we are going to make them into negative values, so we are here. Next, what we want to do is move our ship a bit to the right and up, so that we are not outside of the bounds constantly. And in our code, this is the second calculation, vector2.scale. We want to scale the teleport offset, so 0.2, 0.2, times the sign of our vector of the world position. So actually, this is not a vector, this is sign of the world position. Okay. So in our case, vector 1 and 1 is the diagonal direction here. So if we are moving here, the sign of the position is plus and plus. So if we multiply the vector 0.2 and 0.2 by 1 and 1, we are still going to move in this direction. If we are moving in this corner, then the sign of this position is minus and minus. So if we move it here and multiply our vector 0.2 and 0.2 by minus, we are going to move in this direction, so it will all work on every corner of our map. Now the code for this will be on GitHub. I will post a link in the description, so you do not have to worry about this. Now, if we are not moving in the corner, we are moving either on the in the x direction or y direction, and we want to teleport our player in regard to this direction. So for the x, if x bounds result is true, then we need to calculate return new vector2 world position dot x times -1. So basically we want to only teleport our player on x-axis, and we want to leave the y position as is. And next we need to add to it again offset, and again we need to multiply the teleport offset only by the sign of the world position on the x, in the x direction, or on the of the x value, and we leave the teleport offset for the y as is. The reverse situation will be if we want to teleport our object on the in the y direction. We need to calculate return new vector2 world position x world position y times -1, and we need to add to it vector2 teleport offset on x and teleport offset times sign world position dot y on y. And basically this is it for our calculations. Let's use this script inside our player script. So for me, my player is moved in the update, and basically I take the input, normalize it, calculate the velocity, and set the transform.position to be a new position, which is simply transform.local position plus the velocity times time.delta time. So I'm not using the rigid body. So how can I use our screen bounce? Let me save this script. Basically, I want to create at the top a reference, public screen bounce, screen bounce. To stop my player before I set the transform.position, I need to check if screen bounce reference dot mi out of bounds passing the temp position that I want to set for my player. If this is not the case, I want to proceed with setting the transform.position equals temp position. Now, if I am outside of the bounds, I can basically keep my old position. So maybe if this is false, I can set the transform dot position to be the temp position. If I save it now and go back to Unity, I need to assign to my player the screen bounce, and if I press play, I will see that I will now not be able to move outside of the bounds. Of course, I can add some offset depending on the direction that I am moving in, but basically this works as expected. If we go back to our code, instead of checking this and checking if this is false, we need to check if this is true, and else we are going to proceed with setting our position to the temp position. In case this is true, we need to calculate vector to new position equals, and we are going to call screen bounce dot calculate wrapped position, and we are going to pass our temp position. So this is the new position that we have, we are moving into, and next we are setting the transform dot position equals our new position instead. And now our ship should be teleported on the other side of the screen. Okay, if I now press play, we are going to see that now our ship is wrapped around the screen. But we have some issue that if we move near the corner, basically something strange can happen because we are not sure at which side we are going to appear. So what we can do is modify slightly our screen bounce script. Okay, so I will add another serialized private float corner offset that is equal to 1. If we slide down in the mi out of bounds, we will get the correct information if we are out of bounds based on the real size of the bounds of the box collider. Now below we can add to the check to the part the mathf.abs box collider bounds mean x and y. We can actually subtract from it corner offset. So basically, since we are getting the max mathf.abs absolute value, we are getting, for example, 13 or 28, and if we subtract from it 1, more often we are going to experience this corner situation where we are teleported on the to the opposite corner. Okay, now if I press play, we are going to see that now if I go near the corner, we are going to get teleported on the other side, and this will happen more often than previously, but now we are still going to experience the issue that if we get closer to the corner but not exactly to the corner, we are going to be teleported up. If we get a bit closer on the other side, if we get a bit farther, lower. So this might be a small issue, but I think still we're going to get much more consistent experience compared to what we had previously, where we were teleported all over the map. Okay, great. Now we still have one issue with that our bullets are not affected by our bounce. So what we can do is right click, create a new C# script. Let's call it wrap trigger. And this will be a simple script that we are going to place on our bullets or on any other rigid body that needs to be wrapped. I'll have this test bullet, and I will add to this wrap trigger empty game object. Now we need to have another script. So let me create a new C# script, and this will be bounce wrapper, and let's open this script up. Okay, let me paste the code here, and this will have private serialized field private screen bounce. And we are going to also have the method that we are going to assign to our Unity event that we have created for our screen bounce. This was this exit trigger fire that passed the collider 2D. So we will create public void test collider for wrapping collider 2D to the collider. And we are going to check if this collider contains the component, so get component wrap trigger. We are going to calculate the vector 3 new position based on the screen bounce that we have. So screen bounce calculate wrapped position, and we are going to pass collider transform dot position. And if we have this wrapped position, we can simply apply it to our collider game object transform position equals the new position. Now if we save the script, let's go back to Unity. Great. All we need to do is select our screen bounce and add here our bounce wrapper. And we need to set the exit trigger. Let's add to it a bounce wrapper, and let's set the function bounce wrapper test collider for wrapping, and for screen bounce, for the bounce wrapper we need to assign our screen bounce. So make sure that your bullet has the wrap trigger on it, and now if we press play we should see that our bullets should be wrapped around the screen, and as you can see it all works. They will be deleted after some delay, and we can apply this script wrap trigger on any rigid body that so that it will also be wrapped around the screen automatically. If you want to learn more about making 2D games, and especially about improving your coding skills by learning design patterns that will improve your code architecture and maintainability of your codebase, check out my video courses. The link will be in the description. Thanks a lot for watching. Take care.